Morning to all. Welcome to my channel Education for All. Today we're going to know more about what is the structure of atom. Okay. First, let's know what is matter. Anything you know about matter, anything that have mass and occupy some space is known as matter. The smallest unit of matter is known as atom. Simply, smallest unit of matter is known as smallest unit of smallest unit of matter is known as atom. Atom cannot be divided into smaller particles. Atoms are not divisible. Okay, that is the very smallest unit of matter. According to ancient philosophy, atoms are the smallest unit of matter that can be divided into smaller components. When we divide matter smaller and smaller components, we reach a stage where no more division is possible. That is, when we divide the matter, we reach at some stage by which we can't divide it anymore. That is known as atom. Let's take an example. Let's take a brick. We need to break it, and we give at a some time we get a stage which cannot be further divided. We cannot divide that part. This is known as atom. This is the structure of atom. This is the picture atom, or we called it paramanu. In India, Mahorshi Kanad also proposed a similar philosophy. If we go on the dividing matter into smaller component, a stage will come when particles cannot be divided any further. According to Kanad, this is the definition of matter, atom. These particles are called paramanus or atoms. According to modern theory, this is a philosophical theory. This is not proven. But according to the modern theory, there are so many technology that discovered it. They experimented it and found what is the actual definition of matter. Modern theory was developed by scientists at the end of 18th century. This theory was based on the experiment, not on the philosophy. As for this theory, the difference between element and compound, there is a difference between element and compound. What is the difference? Element means composed of same kind of atom, but compound means composed of different types of atoms. That is the simple difference. Elements composed of same kind of atom, but compounds composed of different kinds of atom. These different elements combine with each other in the following law of chemical combination. The atom combine with each other to form element and compounds. These are by a law of chemical combination. By this process, they combine with each other and form elements or compounds. If there is same kind of atoms, then it is element. If there is different type of atom, then it is known as compound. This is the picture. Left side is the element, right side is the compound. Here is the blue particles. All atoms consists of blue. That means same kind of atoms, but this side is blue and green. That means composed of different kind of atom. That is known as compounds. Then law of chemical combination. What is law of chemical combination? Now this is the fundamental of chemical science. This is known as chemistry. These laws were divulged by scientists Lavoisier and Frost. These laws were found after performing a number of experiments and chemical reactions. They can find the law by performing so many kinds of experiment in the chemical reaction. Then she found two laws of chemical combination, that is law of conservation of mass and another one is law of constant proportion. Okay. Here we divide law of chemical combination into two types. First one is law of chemical combination. Second one is law of constant proportion. Then what is law of conservation of mass? This is given here is the picture of law of conservation of mass. First we take a solution, that is HCl, hydrochloric acid. Then we mix it with sodium hydroxide, NaOH. Then it becomes the solution of sodium chloride plus water. First one is HCl, second one is NaOH. The HCl and NaOH both are the reactant in the chemical reaction. Then we find the product NaCl plus water. These are the reactant, and what we finally got, this is known as the product. This is completely known as a chemical reaction. The first one is first two one which we add, which take part in the chemical reaction, that is known as reactant, and what we got finally after the chemical process, by the experiment, by the chemical reaction, what we got, that is known as the products. Here two substances react with each other to form new substance, that means HCl and NaOH. Two other substances react with each other to form sodium chloride plus water. This is called a chemical reaction. What we said, let us take a look at the different aspects of the chemical reaction. First one is, what are reactants and products? I already told you about that. What are the reactants? During a chemical reaction, one or more substances react with each other, that is known as the reactant, to produce one or more other substance. That means in a chemical reaction, there are one or more substances react with each other to form another one or more substance. The substance which react, that is known as reactant, and finally after reaction, what we got, one or more substance, that is known as the products. The substance which undergo chemical change are called reactant. The substance formed after the reaction, that is known as product. Give an example. When calcium carbonate is heated, it produces calcium oxide and carbon dioxide. That means calcium carbonate is the reactant, is heated. When we heated the calcium carbonate, we got two from it, that is calcium oxide and carbon dioxide. The reactant product, this is the chemical reaction, calcium carbonate, that is calcium oxide plus carbon dioxide. Then hydrogen and oxygen combine to form water. This is the another example. Here is hydrogen, here is oxygen. These are the two reactants which combine in a chemical reaction, which react with each other, and finally we got the product, that is known as water. Then what is law of conservation of mass? What is law of conservation of mass? That means law of conservation of mass is the reactant, the mass of the reactant is equal to mass of the product. That means when in a chemical reaction, the reactant react with each other, their masses never be changed. They remain always same. That means mass of the reactant is equal to mass of the product. Here we take CH4, then it react with oxygen, methane react with oxygen to form carbon dioxide and water. These two are the reactant and these two are the product. We found the mass of methane is 16 gram and mass of oxygen is 64 gram. When we add these two, is equal to 80 gram. That means mass of the reactant is equal to 80 gram. Then in carbon dioxide, mass of carbon dioxide is 44. Then mass of water is 36. Then we also find the weight is 80 gram. That means above the example we finally got that mass of the reactant is equal to mass of the product. What do you observe in the above example? During a chemical reaction, the sum of the mass of the reactant and products remain unchanged. That means the mass of the reactant and mass of the product are remain unchanged. This is known as law of conservation of mass, that I already told you. As per this law, matter can never be created nor be destroyed. Total mass of reactants is equal to total mass of product. According to this law, mass can never be created and destroyed. That means in chemical reaction, both the substances react with each other. That means mass are not created. If there is mass created, then mass will be greater than the reactant. but there is no changes. That means mass can never be created nor be destroyed. That means total mass of reactant is equal to total mass of product. That is known as law of conservation of mass. Let's give an example. Let's take an example. When 100 gram of calcium carbonate is heated, it produces 56 gram of calcium oxide and 44 gram of carbon dioxide. That means in reactant side weight is 100 gram and in product side the product are 56 gram plus 44 gram. That means answer is 100 gram. In reactant side also 100 gram. That means reactant of the mass of the reactant is equal to mass of the product. Let's take another example. Here is the explanation. Hence total mass of the reactant is equal to total mass of product. Note that law of conservation of mass can be applied to physical changes also. This is law of conservation of mass is not only for applied for chemical changes, it is also applied for physical changes. Means when we change physical changes means ice convert into water, water convert into ice, that is known as physical changes. If we take 100 gram of ice is melted, it produces also 100 gram of water. Look at the figure. Here is ice in the bucket that contain 100 gram of ice. When after some time when it melts, we got 100 gram of water. That means it also follow physical changes. Law of conservation of mass applied for physical changes also. Then mass of the reactant is equal to mass of the product. We can say that the sum of the masses of reactant and product remain unchanged. This is another example. In the first side, here is 1 or 2, that is the solution. When we pour the glass, it mix when form the yellow solution. Here weight is, this is the measuring machine. This is the weight is 80 gram. Here is also measuring the weight is 80 gram. That means mass of the reactant is equal to mass of the product. Then next one is law of constant proportion. What is law of constant proportion? Then this law states that in a chemical compound, two or more elements are always present in same ratio by mass. That means in a chemical compound, when two elements combine to form the chemical compound, their ratio are remain same always. It does not matter where the compound came from or who prepared it. It does not depend on that where the compound came from or who prepared it. It only depend on their ratios. That means when we take the example is water. That means in water, hydrogen and oxygen react to form water. Simply hydrogen and oxygen, their ratio are always same. That means hydrogen is to oxygen is equal to 1:8. That means hydrogen 1 and oxygen is 8 ratio. Then we find that water, their masses, their ratio are always same. Then we found the water. Here the example, water H2O is a chemical compound. It contains two elements, hydrogen and oxygen. These two elements are present in constant proportion, that is 1:8. Here mass of the hydrogen is H2, oxygen is 16. When we simplify 2:16, then we found 1:8. It means that in a 9 gram of water, 1 gram of hydrogen and 8 gram of oxygens are always present. We simply said, when we know that the weight of the water is 9 gram, then we simply said that here hydrogen is 1 gram and oxygen is 8 gram. It does not matter where the source of water come from. It is the groundwater, sea water, tap water, rain water, whatever it is, or how the water is prepared, by melting of ice or by cooling of water vapor. This is not depend on that. Only that depend on their mass of the ratio of their masses. Here is the one example. First one is NO, nitrogen oxide. then NO2, N2O, N2O2, N2O5. Here nitrogen oxygen ratio is 1:1. Nitrogen oxygen ratio is 1:2. Then N2O 2:1. N2O2, N2O is equal to 2, 2:2 ratio. N2O5 2:5. Their masses in NO, mass of the nitrogen is 14 and mass of the oxygen is 16. Next one, nitrogen nitrogen is 14, oxygen is 16. Here is 2 oxygen, that means 32. Next one is N2O, nitrogen is 16, 2 nitrogen 28, oxygen is 16. Then N2O2, nitrogen is 16, 14 into 28, then oxygen is 16 into 32. That is their ratio. This is the ratio of their masses. Then we find the final ratio. When we simplify the masses, we find the ratio 1:1, 1:2, 2:1, 2:2, 2:5. This is all about the law of constant proportion. I hope you all understand it. If you have any doubt, then ask me in the comments. Thank you for watching. If you like my video, then please subscribe to my channel. Thank you.